Again, thank you for joining us. What we're going to be talking today about is Smart Clean and a technology that SmartCover Systems has developed. We've been around for 12 years, and over those 12 years, we've learned quite a bit about things that happen in sewers and how you can monitor for those things and how that might help your life and your operations do better jobs. If you could imagine a future, you could do things like listen to your sewer, like a pipe could talk to you and say, for example, you don't need to clean me, everything's all clear. Or there was a rainstorm and it left some grit in my pipe and I need to do something about it. Or maybe there's fats, oils, and greases that are starting to get thick and you need to come clean me. Or maybe there's no problem at all. Or there's a place where maybe there's a few roots that are starting to grow and causing some issues. Right now, the way people clean, obviously, is that they go and they see where things are happening, scheduling cleaning on a monthly or quarterly or maybe annual basis, and that's all based on a schedule and the feedback you get when you go to these locations and find out what's going on. But what we're going to talk about today is actually using real-time data, real-time continuous data that you can look at on your desktop and let that tell you how you can clean better. So a little bit about the company. We are a San Diego technology company. We've been serving the water industry with smart technology for, this is our 13th year. We've got more than 3,000 installations around the country, and we've accumulated more than 135 million operating hours of data. So we've really gathered a lot of data from a lot of places around the country, and all this data is actually helping us learn more about how sewers react to different situations and how you can react to those things yourself. The company has put together 14 patents to cover the things that we do, and we've got a number of product lines including level monitoring, smart level, smart flow, smart rain, and smart tide and smart trend. You might notice that there's a common word there, and that's because we think what we're doing is using the information we're getting from our monitoring and helping people make more smart decisions. This next slide kind of talks about the value of real-time monitoring. We've been told that what we really do is real-time condition assessment. Some of you probably have done condition assessments before in the past, where you want to take a snapshot of what's going on in your system. And real-time condition assessment allows you to actually know what's going on in real time. The problem with condition assessment is, A, it's expensive, and B, you know what's going on when you did the condition assessment, but you don't know how fast things are changing, and if things are changing, how bad they're getting. Really what we're going to be talking about today is optimized cleaning and SSO prevention. So we're going to be focused on that particular aspect. We also do I&I assessment and CSO monitoring, but that's not the topic for today's discussion. Really the goal, of course, is to lower operating costs, lower costs for your agency, and get better results. People have been talking about this concept of the Internet of Things for quite a while, but we've actually been doing this since we started. And really the Internet of Things is a combination of sensors, communication, analysis, and decisions. So the sensor part is being out there in the field, communication is talking to those sensors back and forth, analysis is understanding what the data is telling you, and then obviously the most important thing is how you make decisions from that information. Not just the fact that you've got data, but you need to make decisions about that, and that's what we're going to be talking about today. This next chart talks a little bit about how the system works. I know it's a kind of a busy chart, but really what I want you to do is sort of focus down here on the lower left. That's a kind of a cartoon of how our system works. It's attached to a manhole cover. There's no confined space entry to put our system in. It watches water levels continuously, measures every hour. It sends information back. If the water level gets to a dangerous level, it will tell you right away that you've got a problem. We use the Iridium satellite network for two-way communications. The reason we do that is because probably the times you really want to know what's going on in your sewer system is when the weather's bad or things are going bad in your local locality, and you can lose things like cell phone networks. So the Iridium network is a very, very robust network. It's there all the time. It's used by the U.S. military, so it's a very robust system, and that's why we use it to monitor your sewer system. That Iridium system then talks to its ground stations that talk to our secure servers here in San Diego. So this is a cloud-based system. The data then shows up on your laptop, on your desktop, on your iPad, or on your smartphone, and you can talk also. And it's a two-way system. You can talk back to these sensors that are a long ways away and change set points, for example. So it's a fully integrated system. It doesn't require any power, any communications. That's all built in, and that's kind of how the whole system works. So that's how the technology works. Let's talk a little bit about cleaning and overflows. Most overflows really are a result of capacity issues, and the tipping point occurs either during peak flows during dry weather, where you might have a problem with a small blockage in your pipe, or they also occur with I&I. And a few facts about blockages, and you guys already know this, most blockages are progressive unless you have a vandalism event where someone's throwing something into your sewer. They take a while to build up, so things take a while. Causes are standard things like tree roots, fats, oils, and grease, sedimentation and grit. When you have I&I, that tends to bring dirt and sand and that sort of thing into your system, and once you have that there, it stays there until you clean it out. And the last one, of course, is things like pipe decay, which is becoming a more and more important issue these days. I could tell you a story about a local utility, Escondido, that had a recent pipe collapse that we helped them save a really bad spill by noticing that there was a problem long before a backup occurred into a business. The conventional solution, and it works quite well, is to clean. Just clean as much as you can. But the problem is that the limiting factor with cleaning is it's open loop. There's really no ongoing feedback. You do get feedback when you visit the sites, obviously, and you can figure out, gee, did I really need to be here this day? Or I'm sure glad I cleaned it because we got a lot of stuff out of that line. But basically, between cleanings, you don't know what's going on, and that's really the danger. And so, what a good manager tends to do is obviously look at if I think there's a problem here, I'm going to clean as often as I can. But the more often you clean, there's a couple things that happen. It costs a lot of money, and it takes a lot of time of your staff. Obviously, overflow impacts human health, environmental impacts, bad press. You could have political turmoil, but people get mad about things like that. And obviously, there's unplanned costs. Anytime you have a spill, you have an unplanned cost. Recently in San Diego, you've probably heard we had a spill here of I think 250 million gallons that came out of Mexico with this really bad rain event. And who knows how much that's going to end up costing both California and Mexico in terms of mitigating that. So the concept is maybe we can use smart technology for optimizing cleaning. And really figure out what's going on. So we're going to talk about a case study that we did with San Antonio Water System in Texas. They had a cleaning routine where they have 204 sites that were monthlies and 620 sites that are quarterlies. Now, San Antonio is a pretty large system. They've got about 100,000 manholes and about 5,000 miles of pipe, so it's a pretty large system. Their cost of cleaning, they figure, were about $500 per site per instance. That number probably changes for your district. It's all dependent upon how many folks you have working and how many trucks you have out there. But in their case in San Antonio, that amounts to 2,448 monthlies per year at an annual cost of $1.2 million. So it's a lot of money. The question is there a better way of doing this? And really what I want to talk about is how sewers can talk to you. So I go back to that first slide where we were talking about the sewer talking to you. The sewer really has an EKG. If anyone's ever had an EKG, you look at this heart pattern and you can see what's going on there. If there's any anomalies in that heart pattern, your doctor will send you to the hospital or send you to a cardiologist to get that fixed. Well, it turns out that sewers themselves actually have an EKG. That they have a pattern that happens on a daily basis. And for those of you that are familiar with flows, this is a pattern that you typically see. You tend to get a big lump in the late morning and then also in the early evening that are associated with domestic usage. And 3 o'clock in the morning, there's not much going in the sewer, so the flows are very low. So you get a pattern like that. And it's that pattern that actually we're looking at. And if we can see changes in that pattern will tell you there's something going on in the sewer, just like an EKG will tell you there's something going on around your heart. So how do you listen to a sewer? How do you hear it? This chart kind of talks about what's going on there. There's upstream and there's downstream, and we're measuring at a manhole. We can see what's going on upstream and downstream. And that picture down below is, again, sort of what a typical flow looks like. So the smart solution is let's do this pilot demonstration. Let's see what's going on in terms of using technology to reduce risk. In the SAWS case, we had 10 sites that were set up between August 15th and July 16th. The sites were cleaned smart covers were installed and then added to the system map, and then we performed this trend analysis. We looked at those patterns to see how they changed, and from that change find out, they would base their cleaning based on whether those patterns told them they needed to go or not. So they would only issue a cleaning order on these monthlies when the pattern was significant enough to say, this is showing that we've got a problem. So a few observations. Everybody's collection system is unique, and every manhole and pipe section is unique. And your field guys probably know that. They know their system like the back of their hands. They know which parts of the system are problem areas and which ones are not. Also, dry weather and obviously wet weather are different. And the dry weather patterns are easier than the wet weather patterns because obviously when you have wet weather patterns, you have I&I affecting what's going on, and that can cause changes in your water patterns. Obviously, what we want to do when we're listening to our sewer is during the wet weathers, those are anomalous patterns that are not included in the analysis. But there are a few basic truths that stand out. The patterns will talk, and they'll take time to interpret the language. So let's look at some of these ideas. What's a characteristic of a normal dry weather flow? Well, the standard pattern stays the same. Your EKG is nominal. It looks more like it normally does. In residential areas, you get that double hump, and in industrial areas, it sort of depends. And but you have weekly patterns too. Weekends and weekdays are different. And there's the standard Super Bowl pattern, right, where at the beginning of the Super Bowl game, there's no flow in the sewers because everybody's watching the game, and at halftime, everybody's going to the bathroom and using the toilet or the sinks, and all of a sudden you have a big flow. That's a kind of an obvious situation of how social norms can change sewer patterns. In the case of a normal situation, the minima don't rise. There's no grit buildup, and the maxima don't have an increasing pattern. So that's the thing that we're looking at for these patterns, and we do this automatically with our software that can tell you that these things are happening. Here's an example. That's a very healthy-looking curve of what water levels look like as a function of time. This is a week in 2015. You can see the high levels and the low levels are all pretty much the same. That's a nice-looking sewer. Things to be cleaned there. Here's another example, same kind of thing, where you've got the minima that are not changing, the maxima are not changing. Things are pretty much all the same. The daily differences are there, but you can see that there's no overall trend or anything going on that would betray that you've got to go out there and clean something. Here's another example, just the same thing. I feel good. Your system is looking good under those circumstances. But let's look at what happens if you have some grit buildup. This is an example of a location in Los Angeles. Where you can actually see the water levels change over time. And these water levels were actually caused by rain events. So rain events occurred at this point, grit came into the system, and the water levels rose. So you have the same pattern that's sitting on top of grit, and as those patterns change, you can say, you know what, there's something going on there. In this case, this was Rick Carver for the city of Hawthorne. He said when he got out here, I better go out there and do my cleaning. So what he was looking at was how these patterns were changing. He cleaned the system, and the water level went back down to normal. So that grit was removed, and this pattern was telling him, hey, there's something going on. So he made the decision, I'm going to go out there and do this cleaning. So this is not something where we can tell you exactly what's going on. It takes a while to learn what these patterns are doing, but the whole point about our system is we can give you that information and help you make those decisions. Here's another great example, and this is a really good one. This shows what's going on here. There's not really much going on in terms of this water level in this graph, but if you blow it up, you can actually see that it is rising. And what's interesting here is that in the old days, when you'd send folks out to say, hey, go check these problem holes and see if we need to do something, you'd send a guy out, he'd open up the manhole cover and look down and see if the flow was okay. Well, obviously, number one, he's looking at one point in time, and number two, his human eyeballs are not as good as a computer that's looking at this, 7 days a week, 24 hours a day. And what we're seeing here is a very small and subtle water rise. It's only about a half an inch or maybe a little bit less than that over a period of a week. But clearly there's something going on in that manhole. There's some kind of grit building up. So that causes them to perhaps do something about it. So what does a downstream buildup look like? How does that? What kind of patterns would that show? Well, here's a little cartoon that would kind of show you what happens when you have a downstream buildup. A downstream buildup is really, again, a capacity issue. It's effectively like you have a smaller pipe downstream because the flow through that pipe has been restricted. And this is an example of what that pattern would look like. You can see that there's a normal pattern going on here, but there's been over a period of time there's been a buildup of that pipe. And what's going on here is the maxima are increasing. At low flow, the water is going to be flowing fine because having a smaller pipe downstream is not a big problem. But at high peak flow times, you can see that the maxima are rising. How about the same thing upstream? What if there's something going on upstream? That would be if there's a blockage upstream. How would that change the patterns? Here's a perfect example of what might happen with an upstream problem. You can see these normal patterns going on here for a few days, and then bang, the water level drops. That's a clear indication that there's something going on upstream. That you say, hey, let's send the guys out and take a look at this, or let's send the truck out and clean that upstream pipeline to fix that problem. Here's another example of the same kind of thing where the water levels drop over time. That's a clear signal that you ought to be sending your truck out to do cleaning. So here's the really good news about the SAWS pilot, which may or may not be indicative in general, but it is a very eye-opening situation. They were cleaning these problem areas once a month, and over the period of a year, for these 10 areas, that would be 120 cleanings. Well, using the data that they got from the SmartCover product and using the Smart Clean concept and looking at trends, they ended up only cleaning 7 times. The interesting part is they had no spills. So they really effectively got the job done, which is to have no spills, and they did it by cleaning 94% less than they would have without having this information. So that really can correspond to saving some money. So the financial impact of this could be pretty significant. In the case of San Antonio, that had 204 high-frequency zones, their annual costs, looking at it from a bottom-line standpoint, are about $1.2 million. Let's just say they did 85%, because 94% is just a mind-boggling number. Even at 85%, the savings would be $1 million. The startup costs were $699,000. Annual costs, years 2 through 5, would be $590,000. So the total savings over 5 years is $2.1 million for SAWS, and that's only at these high-frequency cleaning sites. So it's really a very important thing. They're now going to implement this pilot program and put this at all their high-frequency cleaning locations starting in a few months. So just to kind of give you a summary, the process that we use here is to look at the water patterns in the sewer, use those to help you decide when to clean as opposed to using a calendar. You get a productivity gain. Your personnel equipment can be redirected to more critical tasks. You get continuous protection from an SSO because you're always monitoring these locations. You're not just going out once a month or once every few months. So you have full monitoring between cleanings. You know what's going on in each case. You have lower risk for your crews. There's less time in traffic. You have lower carbon footprint, which is a very positive thing from a political standpoint. And another important thing is you have extended asset life, because every time you clean a pipe, whether it be high pressure water or you might use cutters to get rid of roots, you're doing something to that pipeline that's ultimately going to reduce its lifetime. And as you get to pipelines that are getting older, we've had some customers that have actually stopped cleaning because the next time they clean, the pipe's going to fall apart. Those sites need to be monitored. Then you know what's going on all the time, and you can sleep at night and not have to worry about sewer spills occurring at 3 o'clock in the morning. So I'm just going to put this on. Let me see if I can do this right. I got to put on my speakers.
Hi, I'm Angela Godwin for Water World Magazine, coming to you from the show floor at WEFTEC 2016 in New Orleans. Joining me today is my guest, Elisa Lockett. She is with San Antonio Water Systems. Elisa, thank you so much for being with us today.
Thank you for inviting me.
So why don't you tell us a little bit about what you do for SAWS before we get into the little case study I want to talk to you about?
Well, I'm a director of construction and maintenance in the distribution and collection operations department. So we work mainly with the pipelines, and my particular group does all the sewer maintenance for the most part. We do the line cleaning and televising, and then we also do the sewer repairs.
Excellent. Now, I understand that you have a very interesting story to tell where you were able to take smart technology effectively to really optimize your maintenance program. So let's talk about that. What did you guys do?
So we have had SmartCovers, which is a manhole level monitoring system, for over, I think, about 7 years, since 2009. And we had primarily been using them to babysit pipes that were in poor condition. Well, we worked with SmartCover to do a pilot where we actually put 10 units on pipes that had been on a very high cleaning frequency. So pipes that have lots of grease that were on a cleaning frequency of about a month. And so we were cleaning each of those pipes 12 times a year. So that's 120 times for all 10 of those pipes. And so we put 10 units out, and the agreement was that we would only clean them when the trend line showed that we needed to go out there. And so the level was monitored daily. It was real time. And so we found out that we only had to clean those 10 pipes 7 times out of 120 that we would have normally had to do. So it was a 94% reduction in how much we had to clean those pipes, and we only deployed 10, but we have hundreds of pipes just like those that are subject to a lot of grease that we're cleaning on a 1 or 3 month frequency, and so we think that this is going to be a huge savings in our costs for cleaning, and we can really optimize our cleaning.
Excellent, and not just cost, but like that time, manpower.
Drive time, the huge vehicle on the roadway, our carbon footprint, everything would be way optimized by reducing the amount we're having to send a Vector truck out there to clean.
That is amazing. So is the pilot still ongoing, or are you planning on rolling those out to the rest of your system?
So the pilot ended in July, that was a year, and now what we're looking at doing is in the next budget year, widening that program to about 200 to 300 manholes, which would be on pipe segments that are also subject to frequent cleaning due to grease. And so that's what we're looking at to try to get the budget to do that, because we think that this is going to reduce our costs for those particular pipe segments as much as $25,000 to $4,000 in a year.
Oh,
so
wow.
It'll be huge.
That is amazing. And the alerts that you get now, how does it let you know when there's an issue?
So an email actually goes into our emergency operations center, and then they deploy a service request to one of our team that does the line cleaning, a combo, and then they go out there and respond to that service request.
That's awesome. It's such a great example of the industrial Internet of Things that we keep hearing so much about. So we wish you all the best of luck going forward. Thank you so much for coming by.
Thank you. Thank you.
For Waterworld Magazine, I'm Angela Godwin.
Just as a kind of a final slide, don't clean lines. Clean only when you need to clean. Your sewer can actually talk to you if you know how to listen to it and tell you when to clean. And using Smart Clean you costs help you meet your tight budgets, which are a big problem, especially here in California, where we've had a reduction in our ability to sell water by 25%, and that's put really strict budget problems on everybody. And again, no spills at the same time, because your system's telling you when you're going to have problems. So it's a predictive system as opposed to a reactive one. So thank you very much. I hope this was time well spent for you. And I'm not sure how we do questions. I think there's a chat box there. But if you have any further questions, you can also email smartclean@smartcoversystems.com, or feel free to contact me, Greg Quist, gquist@smartcoversystems.com, and I'd be happy to help you out or send you in the right direction. So hope this was a good time for you, and have a great day, and thanks again for your participation.